This video, I'm going to go through notes and examples for section 9.5. This is covering the sine and cosine functions. So these act exactly as tangent does. We solve the problems exactly the way that we do with tangent. So if you're struggling with that, maybe go back and get to the point where you're feeling good about tangent before we move on. If you are feeling good about tangent, this is going to come, this should be pretty straightforward. The only difference is that sine and cosine are a ratio of different sides. And so we see this kind of model on the left that goes with the diagram on the right. And can kind of simplify this a little bit. So we know that tangent is the ratio of the opposite over adjacent. And now we're adding sine, which is the ratio of opposite over hypotenuse, and cosine, which is the ratio of the adjacent side over the hypotenuse. And remember, the tangent, sine, and cosine are always of some angle, so we're going to have something here, either an angle measure or a letter of an angle. What I'm doing here is just showing you those different ratios. And we have this model kind of down here on the bottom as well. So this SOHCAHTOA, that's what we say SOHCAHTOA. And this helps us remember these different ratios. I'm not sure where this came from. Been around for a really long time, just as a tool to help us remember. And what this means is this first portion, SOH, tells us that the sine is the ratio of opposite over hypotenuse. CAH, cosine, adjacent over hypotenuse, and then finally tangent, opposite over adjacent. So if you can remember this, you should be able to remember these three ratios. So moving forward, we're going to kind of just start by kind of recognizing these ratios and writing those out for some sine and cosine models. So first, I'm going to look at sine of R and sine of S. So this is the model on the right. And so if I want to know the ratio of sine for angle R, this is my angle R. And if we look right above, sine is the ratio of opposite over hypotenuse. So for angle R, this is the opposite side, 16. Hypotenuse is this side here, the 65, because that's across from the 90. So the sine of R would be 16 over 65. And the sine of angle S, similarly, so for angle S, the side opposite of S is 63. Hypotenuse is still 65, so this would be 63 over 65. Now this would be a good place to pause and kind of think about the cosine of R and cosine of S. Try to write those ratios by yourself and then come back and unpause. So cosine, I'm going to look at cosine of R, cosine of S, cosine of R. So cosine is the ratio of adjacent over hypotenuse. So for angle R, 63 is adjacent, 65 is hypotenuse. So this would be 63 over 65. And the cosine of angle S would be 16 over 65, using those same methods. Moving on, there's this relationship between sine and cosine. And this next question is asking us to write the sine of 65 in terms of cosine. And what this means is, so if we think about the sine of 56 degrees, we know that is some ratio of sides. So the question this is really asking is, so something like this. So we say the sine of 56 degrees is the same ratio as the cosine of what? All right, so the cosine of what angle is the same as the sine of 56? And before we kind of get into these models up here, it's going to be easier if we think about a diagram and what this triangle and ratio might look like. So if I have some triangle, and remember this only works with right triangles, and I know that one of these angles is 56, And if I'm thinking about the sine of 56, I'm just going to label these sides with letters. So these letters represent the side lengths. This is just going to kind of help me determine what this ratio would be. So since sine, and I guess let me just write this so we have kind of a reference. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So the sine of 56 is opposite over hypotenuse. So the sine of 56, it would be equal to the ratio of b over c. And what we want to do is we want to write the cosine of something is this same ratio. And if we think about it, it's going to be this angle over here, right? Because cosine is adjacent over hypotenuse. So the side adjacent to this angle would be b, and the hypotenuse is c. So we know that the cosine of that angle, we're going to figure out what it is in just a second, is also equal to b over c. So that's what we want, the cosine of this angle over here. And we can figure this angle out because we know that the angles in a triangle all add up to 180. And we can break that down even further because we've already got 90 here. So we know that these two must also add up to 90. So this angle, whatever it is, must be equal to 90 minus 56. And 90 minus 56 is going to be 34. So this angle is 34 degrees. And therefore the cosine of 34 has this same ratio as the sine of 56, and that would be our answer. So if I want to write the sine of 56 in terms of cosine, that would be the cosine of 34. And this is always going to be true. So this idea that the sine of this angle over here is the same ratio as the cosine of this angle over here. And we could flip the order as well. The sine of 34 is also equal to the cosine of 56. So whatever these two acute angles are, the sine of one is equal to the cosine of the other. And that's kind of what we're getting at when we look at these different equalities up here. So the sine of some angle A is equal to the cosine of 90 minus A. And that's how we got this 34, right? If angle A is 56, 90 minus 56 is 34. So this just gives all the different ways that we can think about this. But for me, this model, this triangle model down here, is an easier way to think about this relationship. So again, I would pause, answer number 3 on your own, and then come back and just kind of check your answer. So number 3, we can draw another little model again here. Okay, we know we've got a right triangle. I know my one angle is 23 degrees. I just picked that one because it looks a little smaller in my model. And I can find this other angle. All right, I can find this one up here by doing 90 minus 23. And we do 90 minus 23, and we get 67. So this angle must be 67. So that tells me that the cosine of 23 is equal to the sine of 67. Okay. And this is one of those ideas that might just take a minute to kind of set in. So if you need to stop and you need to watch this and think about this a little bit more, that's totally normal. I would recommend doing that. Moving on, let's look at solving some problems using sine and cosine. So if I look at this triangle down here on the right, our thought process for this is going to be a little bit different. I want to walk you through that. We could start with either of these variables, x or y. Doesn't matter which one. I'm going to start with x. And so what we need to do is we need to figure out which ratio we want to use. Okay, so I know I have this angle 26, and I want to know x, and I do know 14. So the thought process should go something like this. If this angle is 26, and I want to involve these two lengths, right? Because that'll be enough information for me to solve for that x. So I want to think about what sides these are related to 26. So x would be the opposite side of 26. This is our hypotenuse. So I want to go back and I want to look at my three trig functions and I want to think about which function involves opposite and hypotenuse. And that's the one I want to use to set up my equation and solve for x. And this would be, again, a good time to kind of pause and think about this yourself, look up which relationship that is. It is the sine relationship. So the sine, we said, is opposite over hypotenuse. So our equation would look like this. The sine of 26 is equal to opposite x over hypotenuse 14. And just like we did for tangent, we can plug the sine of 26 into our calculator and get a number, right? Remember, that is a ratio. And when we punch this in, the sine of 26, we punch that into our calculator, we get 0.438. So I'm just going to substitute that in. 0.438 is the sine of 26, and that's equal to x over 14. This is a one-step solution from here. If we just multiply both sides by 14, so 14 times 0.438 is equal to 6.14 if we round. So x is equal to 6.14. We're going to do the same thing for y, right? And now we're going to use the same angle, 26. And now y is the adjacent side, and 14 is the hypotenuse. So this tells me that the function I want to use is going to be cosine, because cosine is adjacent over hypotenuse. Okay, so the cosine of 26 is equal to y over 14. And solving this is the exact same process. I can punch the cosine of 26 into my calculator, and I get 0.899. So the cosine of 26 is 0.899, and that's equal to y over 14. Solving is the exact same process. Multiply both sides by 14. And again, we'll just punch that into our calculator. 14 times 0.898. And we get 12.57. Y is equal to, running out of room a little bit here, 12.57. This is the same, this is kind of the standard process. This is the same idea we use for tangent. The only difference is now we need to decide which function is going to be most appropriate to use. And sometimes if we know both angles, you have more than one option, and it's just up to you which one you're going to choose to use. From here, I would try these next three problems on your own. Hey, we have enough information. You have models that you can look at. I would try these three, and then I'm just going to go through solving these last couple problems pretty quickly, and then you could check your work that way. Okay, so if I'm looking for u and t, so now I'm moving down to number 5. I'm looking at this model, looking for u and t. Doesn't matter, again, which one I do first. I'll just do u first. So angle 65, u is my adjacent side, 8 is my hypotenuse. So my equation I would set up would be cosine 65 equals u, that's not a u, u still doesn't look like a u, u, there we go, over 8. Cosine of 65 goes into the calculator, 0.423 equals u over 8. Multiply by 8 on both sides, and we get approximately 3.38. U, keep wanting to draw y's here. U equals 3.38. Similarly for t, if we're still using the angle 65, t is opposite, 8 is hypotenuse, so the sine of 65 equals t over 8. Sine of 65 is 0.906 equals t over 8. Multiply both sides by 8. And we should get about 7.25 times 8 times 8. T equals 7.25. Moving on, these ones with the special right triangles. Okay, so I'm looking for sine and cosine of 30. So I always recommend drawing this model. And when we were originally working with these models, we said if this is a 30, 60, 90, we said that this side would be like n, 2n, n square root of 3, where n can be any number, right? This just tells us the ratio, how the sides are related to each other. For these models, it's going to be beneficial if instead of n, we just use the number 1, right? Because we want actual numbers in here. And these are the simplest numbers we can use. So whenever we're doing these special right triangles, we want to find the sine and cosine. We don't want a decimal answer. We just want to leave it as some sort of fraction. There's probably going to be a radical in there as well. So unless it specifically asks you for a decimal, just leave it as a fraction. So 30 degrees is the angle we're looking at, and we want cosine. Okay, so the cosine of 30, and cosine is the ratio of adjacent over hypotenuse. So adjacent is square root of 3, hypotenuse is 2, and that's it. We can leave our answer like that. It doesn't need to be simplified anymore. Sine of 30 is opposite over hypotenuse, so opposite would be 1, hypotenuse is 2. The sine of 30 is 1 over 2, or 1/2. That's it. If you end up with a radical in the denominator, you will need to simplify a little bit, but otherwise, you're good to go. That's it. Finally, number 7, skiing on a mountain. Find the distance x you will be from the base of the mountain. So if you think about, we have some mountain over here, right, and you're at the top, and we know that we have this height of 1,200 feet. If we think about skiing down the mountain, this will be the approximate distance that you ski as you're going down the mountain. And we call this 21, we call this the angle of depression. So if we look straight and then we look down at this angle of 21 degrees, and that's the angle we look at to look at the base, we call that the angle of depression. So if I want x, if I want the hypotenuse, I have my angle here. The side I know is this 1,200, and that's the opposite side. So if I know opposite and I want hypotenuse, okay, sine is my relationship. Sine is opposite over hypotenuse. So that's the ratio that I want to use. So the sine of 21, sine of that 21 is opposite 1,200 over hypotenuse x. Okay, now this one, my variable is in the bottom, so we're going to have to do a little bit more work, just one extra step. First, let's find that sine of 21. Okay, that comes from our calculator, 0.358. 0.358 equals 1,200 over x. Now with that variable in the bottom, remember we want to multiply by that variable, because what that's going to do is, remember this is like x over 1. Those variables are going to go away on the right-hand side, and we get 0.358x equals 1,200. Divide by this 0.358. 0.358, and that'll give us our value of x. So x is equal to 1,200 divided by 0.358. 0.358 equals 3,351. 3,351. We could take some decimals here if we wanted, but when we're at 3,351, a 0.9 isn't going to make that much of a difference here.